All right, guys, we have finally made it officially to the last part of this lesson where we are going to solve this polynomial. All right? Now, I asked you when you guys got finished with the previous problems to take a look at those couple of slides, and I want to focus on this theorem, which is called the fundamental theorem of algebra. You're in algebra class. Fundamental, if you know, does anyone know what that word means? Fundamental? Like basic, right? Like basic. The idea being that this is the bottom layer, the foundation of everything we do in algebra. Okay? Now it says a lot of words, all right, but I'm going to translate for you. And basically what it means is if you look at a polynomial, any polynomial, so it's any number of terms, any degree, if you look at the highest exponent, which in this case is 4, that's how many answers you should expect that make this become 0. Right? Ultimately, I want to find out what values for x will make this become 0. That's called solving. All right? We've done this last semester for quadratics. So to the second power. Do you remember how many answers we usually got? 2, because it was to the second power. All right? So hopefully you see that. Now, guys, before we actually get into this, I want to be very clear. We're going to take about 15 minutes to do this problem. All right? It's going to be multiple slides. All right? It's also, if you run out of room because you write big, there's room at the bottom on the back for you to continue. All right? At some point, your brain is going to hurt. Okay? I'm just preparing you for that. But I want you to push through. Okay? Continue to persist. Keep going. All right? Exactly. So here we go. I want to know a number that's going to make this 0. And right now, I could pick any number I wanted. But instead of doing that, I first want to use that theorem I just taught you to narrow it down. All right? So I'm going to use the rational root theorem to narrow it down to possible answers. So first, where do I look? First, I look at 36. All right? What are the factors of 36? 6 and 6. 9 and 4. 12 and 3. 2 and 13 is 26. 2 and 13 is 26. 2 and 18. Very good. We got them all. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. All right, so those are all of our factors of 36. All divided by, what do we divide by?
1.
The leading coefficient, I'm being nice to you, the leading coefficient is 1, so the factors of 1 are 1. So what are my possible answers?
The same thing.
1, 2, 3, 4, 6, 9, 12, 18, 36, positive or negative. All right? Now, we want to figure out if one of those is an answer. So I'm going to start. Pick a number you want to begin with. Keep in mind, who wrote this problem? I did. So what number am I going to check first? 1. So I am going to use a skill you should know. I'm going to put 1 in the corner. Then I'm going to list the coefficients from my polynomial, which are 1, negative 3, 5, negative 27, and negative 36. I'm going to draw my line. And I'm hoping, I'm praying to the gods of math that I get what at the end? 0. 0 in my remainder. 0 in my remainder. If I don't, then 1 is not an answer, and I try again. So let's see. Hopefully you're praying. Let's bring down the 1. 1 times 1 is 1. Negative 3 plus 1. Negative 2. Times 1. Add straight down. Multiply times 1. Add straight down. Multiply by 1. Add straight down. And you get negative 60, which is not 0. So is the number 1 an answer? No. Okay. It wasn't a waste of time, right? We actually have to do it. Now, I know some of you are thinking, because we're going to take a long time to do this problem, Mr. Vrandrick, you do this all the time. You make us do problems that take a long time, and then you show us a faster way. Guys, this is the way. All right? I will show you later on where we're going to go faster, where we could continue to go slow. Yes, there is a slower way. Right now, we're just on the way. We haven't hit the fork in the road. All right, we're just going. This is the only way to start. All right? So 1 didn't work. I could go to 2, but remember, who wrote this problem? So let's go to negative 1. Technically, that's the one that comes next, right? Positive 1 and then negative 1. So I'm going in order. And then, Shiloh, if I don't get it here, I'll go to 2. Alyssa, I'm not just going to skip. Remember, who's going to write all the problems you're going to do? Me. Okay, here we go. 1, negative 3, 5, negative 27, and negative 36. That hasn't changed. But now I'm going to put negative 1 in the corner and pray to the gods of math that this one will work. Bring down the 1. 1 times negative 1. Negative 1. Negative 3 plus negative 1. Negative 4 times negative 1. Positive 4. 5 plus 4. 9. 9 times negative 1. Add straight down. Negative 36 times a negative 1 is 36. Negative 36 plus 36 is 0. We got an answer. I want to be clear. We didn't get the answer. We got an answer. At the very beginning, we said, how many answers do I expect? 4. We have now found one of them. Now, at this point, we could continue with 2 and do this process to see if we get 0. Negative 2, 4, 3, all the numbers. That would be the slow way. We've come to the fork in the road. All right? We could continue down this path and just do this for all those numbers that are up there. Okay? Or we could use a skill that I taught you yesterday. All right? Now, once I find a 0, I no longer work with the original polynomial. I just found a number that works. So I know we use this process as synthetic substitution to look at that, but this is the same work for synthetic division. And when I taught you synthetic division, you can write down what is left using these numbers. What did we start with as the degree of that polynomial? It was 4. What's 1 less than 4? So it's going to be 1x cubed. 1x cubed. See if you can follow along here. Minus 4x squared plus 9x minus 36. So basically, we've started out with this tree, and we want to take this tree and make a chair. All right? So the original polynomial is our tree. We're starting to whittle it down, and we have now whittled it down to x cubed instead of x to the 4th power. Now, in order to make this okay to the gods of math, I'm going to put parentheses because we do need to multiply by something to get back to the original. Am I going to go back to the original? No, but I should show that we still have everything that was in the original. So take a look at what you found in the corner that worked. What is in the corner that gave me this 0? Negative 1. And when we did synthetic division, what did I say? When you pick the number that goes in the corner, you always have to think Opposites. What's the opposite of -1?
1. Positive 1.
So that's why you write that. Okay? So here's a stopping point, a checkpoint. If I asked you to do this, and I'm not going to, but if I asked you to multiply x cubed, -4x squared, 9x, and -36 times each of these, you should get the original polynomial. All right? So have we changed anything? No. But now, since I have found one that works, all I care about is this new polynomial that's raised to the third power. So I'm going to go to the next slide. All right? And if you've already moved on, that's great. So go, basically this is kind of like still the same problem, but we now are hit that fork in the road and we're branching off to go faster, to find these answers at a quicker pace. All right? So I'm going to write down x cubed minus 4x squared plus 9x minus 36. Now off to the side, I'm going to write x plus 1, just so you know that it's still there, but it's just going to come down to the end. So I'm going to repeat that. All I care about is this new polynomial, but this one still needs to be there, so it's going to come down to the end. All right? Okay. Now think back to yesterday. Yesterday I taught you to factor by grouping. So how can I factor this cubic polynomial with 4 terms? I'm going to basically split it in 2 halves. This one, the first part, and the second part with parentheses. All right, what do the first 2 terms have in common? X, we're not going to go see x minus 2. X squared. X squared. It's okay? Very good. X minus 4 is left. What about the next 2? 9. What's the sign in front of 9? Positive. A positive. So I'm going to write plus 9. And what's left? X minus 4. Are you shocked that those are the same in the parentheses?
They should always be the same.
Okay, let me first I'll say is they should always be the same if you're going to be able to use this process. And again, I wrote this problem for a reason so that we can use this. But later on this week and next week, will this always work out so nicely?
No.
Maybe not. And we'll talk about what to do when that happens. Okay? But for today, it will work out nicely like that. So I'm going to write my 2 factors. All right, so what's one factor I'm going to write? X squared plus 9 and x minus 4. Now think back to yesterday, because we did a problem just like this where we had trouble. Can I continue to factor x squared plus 9? No, I can't. So this is completely factored. Yes? I combine x squared and 9 to be a factor. They share this one, so I don't bring down 2 of them. I just bring down 1 of them because they have it in common. Okay? Now, I'm not actually fully factored from the original. There is another term I need to bring down and put right here. X plus 1. So make sure you also bring that down. Question? The sum of 2 squares is not factorable. If this had said x squared minus 9, then you should keep going. All right. Now we already have one answer. What was that answer that we already have? The -1, right? So the idea is I want to set this still equal to 0. What number plus 1 makes 0? What number plus 1 makes 0? All right, so that's the answer we already have. That's nothing new. What about this other factor of x minus 4? What number minus 4 makes 0?
4.
Positive 4. So how many answers do we have now?
2.
2. We still have how many to go? 2. We need 4 total, right? So 1, 2. Where are those other 2 going to come from? X squared plus 9, right? What's the power? It's a 2, so I'm expecting to get 2 answers. All right, so here we go. I'm going to write that in green down here. X squared plus 9 equals 0. I want to move the 9 over. What does it become? -9. How do I get rid of that square? Square root. If it had said 2x in front, Deanna, then you would divide by 2. All right? The square root of x squared is x. But you should have alarm bells going off in your head right now. There's a negative inside a square root. We can't do it. But we did introduce something last semester that allows us to continue. The imaginary term, the letter I. Oh my gosh, it's back! All right, it's back. Now, what's the square root of 9? 3. So how many answers do we have now? We have 1, 2, 3. What? You guys told me I was going to have 4. 1. What did you just say that we can add on here that's going to give us the 4th one? Very good. Positive or negative 3i. So your answers are negative 1, 4, and plus or minus 3, bless you, 3i. That's 4 answers. We're done.